In our last class, we talked about multi-step percent problems, and then we said that the order of a multi-step problem doesn't actually matter as long as it's all based on percentages. So for a discount and a tax, for this example right here, we get the same answer whether we do the discount first, then the tax, or the other way around. We still get the 880 either way. And the reason for this is because of the cumulative property. Because if you're taking $1,000 or any price, and you're finding 20% off of it, you're really multiplying it by 0.8 in order to keep the 20%. And then you're adding on 10%, that would be times 1.1. So if we multiply by 0.8 first and then do times 1.1, that's the same as doing 1,000 times 1.1 and then times 0.8. So it doesn't matter which one we do first, either adding on the 10% tax or we do the 20% discount. Either way, because it's all just really multiplying, if you write it like this, the order doesn't matter because of that cumulative property. Then we did some more examples with tax and discount. Just remember to always keep in mind that the discount is subtracted, tax is added. Again, the order doesn't matter. We saw better deals here on this page 33. $100 off coupon, so here's where it would matter. If we're talking about a coupon for money off, not a percent off, the order is going to make a difference. So we should be careful with problems like that. And then we saw on this page here, 34, we saw a couple other examples regarding the order of things. So for example, if we say 8% discount and then 8% sales tax, those two things are not going to be the same. Okay, if we take off 8% discount and then add back on 8% after it, you're not going to get back to the original. You're going to get very close like we saw right here. But if we take away 8%, that really means you're starting with your $100 example here. Taking away 8% would be times 0.92. And then adding on 8% would be times 1.08. And 0.92 times 1.08 is not 1. So it's not going to keep it the same as what it was before. If you do that, you're going to get the 0.9936 if you multiply the 0.92 times the 1.08. And that's why when you multiply it by 100, we get the 9936. So 0.92 times the 1.08 is that decimal right here. And then again, that's why times 100 is why we get to this price right here. So it's close to what we start with, but it's not times 1, so it's not the exact same thing. Okay, moving on here, we then talked about the different percent kind of problems that we've seen. We're finding the part, we found it by making this percent into a decimal and just simply multiplying, or we could use this proportion right here, part over whole percent out of 100, and find the scale factor and solve it that way. Finding a percent, what we've done a lot of is with the proportion to find the percent above the 100. You could also just make it a fraction and then divide it into a decimal, and then convert that decimal into a percent. That also does work. And then finding the whole, I recommend for these just using the proportion for both of them. If you're looking for the whole total, it's a lot easier to use the proportion. So what you're going to do next is page 36. You're going to start this on your own, and then I'm going to kind of walk you through the beginning of the next page 37. So go ahead and you can pause this Edpuzzle right now and complete this page 36, and then we'll pick up with the next part on page 37. Okay, if you're back, that means hopefully this page 36 is done. So let's look at page 37 now. So we're talking about percent change here. Now, the equation that works, or the formula for this is pretty simple. It's just what is the change divided by the original. That's how we calculate the percent change. So say for example, a car was $100 and now it is $200. It's a very cheap car. What is the percent change? Well, what was the change from here to there? That would be adding on 100. And then we divide that change divided by the original. This is a bad example because they're both the same thing. And that gives you 1, which is 100%. So that would be a 100% increase, which again, not a great example. Let's do maybe about 10 becoming 25. What would that percent change be? Well, the change would be 15 from 10 to 25 divided by the original, which is 10. So that would be 1.5, which as a percent is 150%. So that would be 150% increase. If it decreases, it would just be a negative number here. So the change would be a negative change, which would then just be a decrease for the percent change. So what you're going to do down below here on page 37, you're going to find the changes. So you've got the cost. It is to make each jar. And then you've got the cost that they're selling it for. So you're going to first figure out what is the change by using subtraction. And then to find the percent change, you're going to do the change divided by the original. So these are the original. Those are the original costs to produce it. So you're going to divide the changes you found in A by the original to get the markup for each jar. And then you're going to do some more. This other example down here is another example for percent change. So basically use subtraction, divide it by the original, and you'll get the percent change. Just remember to convert the decimal into a percent.